Okay, so I'm going to be introducing curve fitting and interpolation in this video, just the general concepts, and then in future videos I'll go into more detail about each of the different concepts. So let's just talk about curve fitting in general. What are we talking about when we're talking about curve fitting? So there's two main I don't know what you want to call them, schools of thought, not schools of thought, two different methods. There's interpolation and least squares regression. At least those are the two that we're going to be talking about. So let's say I have some set of data, y versus x. So just a very simple data set. And let's say my data looks something like this. Alright, so fairly linear, but maybe a little nonlinear. So least squares regression means we want to capture the trend of the data in some curve. So we want to find the equation for a line that might look something like this, that fits the general trend of the data. So two basic approaches. Let me write this down. Two basic approaches. Two basic approaches. So there's first one, which is the one I just described here. That's, man, I cannot write numbers today. This is number one. Least squares regression. So that's, okay, regression is the more general term for it. So regression, least squares is a type of regression. It's the type of regression that we're going to be talking about. So regression is one type here, so regression. And that's where we are trying to find an equation or another word for it could be model that describes or captures the trend. So the trend of the data. So typically when we're talking about curve fitting, we're always dealing with some discrete set of data points. So I'll just write that down. So we're deriving an equation to fit to a set of discrete data points. So discrete as in there, it's not a continuous set of data. Alright. Now, so we've talked about the first approach, regression. It should be noted that because regression is trying to capture the trend of the data, it doesn't necessarily pass through all the data points. It could pass through one or more of the data points, but it doesn't have to pass through any of the data points, technically. So that's another characteristic of regression. So curve, so derived curve, doesn't pass through all or any of the data points. Alright, so let's talk about the next approach, which is interpolation. So if I have data that is not very noisy, let's pick some data. Maybe it looks like this. Nice and clean looking. Now, if we compare that data to the data that I drew up here, this data, there's a lot more. If you were to just draw a line that passed through each one of these points, it would be very wiggly. Okay? But if you draw a line that passes through each one of these points, let's use a different color here. Bing, bing, bing. It's a nice, smooth looking curve. So it doesn't wiggle all over the place. So interpolation is where we try to, let's write this down, interpolation. Our objective interpolation is to derive a curve or an equation that passes through all the data points. Alright, so big difference between interpolation and regression is regression, your derived curve doesn't pass through all the data points. It can pass through some of them, but it doesn't have to. It's not the goal. The goal of least squares regression is to capture the trend of the data. Whereas the goal of interpolation is literally to pass through all the data points. And this is nice when our data is not as noisy. And interpolation is typically used to calculate intermediate points. So let's see. Used to find intermediate points. Or data. Alright, now why is this useful? Well, this video is for an engineering class, so I'm going to talk in terms of engineering. So, question: why do we want to fit curves to data? Using interpolation or regression. So any engineer is familiar with tables and tables and tables of properties. Properties of fluids, properties of materials. This is a common thing that engineers have to deal with when they're designing systems. So when we design systems, we have to look up properties. Now, properties of materials, and other stuff. I'm just going to put stuff. Okay, because it's not just materials, all kinds of things. So it's nice to be able to use interpolation to find intermediate points. Intermediate points of tabulated data. So that's one use of interpolation. There are all kinds of other uses in numerical methods and in coming up with solutions to differential equations. There are numerical methods that use different types of interpolation in their methods. So I would say in research methods, okay, you're going to use interpolation. Now what about regression? Well, fact of the matter is, answering this question, why do we want to fit curves that describe trends? Well, the biggest thing is we want predictive power. We want predictive power. Okay, so if I have some data, what if this data describes, stock prices? This is a good example. Okay, so we'll call f of x is in dollars, and it describes the price of a stock. Maybe it's Google stock, and this is time. Okay, and maybe Google stock over the last year looks something like this. Okay, well, classic example is, okay, let's fit some curve to this, and then if this curve is accurate, then we can predict what Google's price is going to be in the future. And if we can predict that it's going to go up, then we can buy it cheap and then sell it when it costs more, and then we make money. That's the so there's a lot of people in the financial industry that are interested in regression, and kind of a more general field related to regression would be machine learning. It's something I'm very interested in. So machine learning. That's kind of a more general approach to teaching computers how to be able to predict and learn. Now, as engineers, we want to be able to predict, well, maybe the behavior of robots. Maybe we want to predict how some system is going to evolve in time, or maybe we have some material properties that we want to predict, but the data isn't nice and concise. Maybe our data looks something like this. Maybe we have the, I don't know, some data. And it looks like this, and then we have got a lot of data points right up in here, and then some experiments over here, and an experiment or two over here, and then some data out here. Let's draw this longer. And then we've even got a few outliers. Okay, this data might have been collected by many experiments, but we're probably going to have some physics model that we fit to this data. that allows us to calculate intermediate values, or even predict what the values would be out here, or much closer down here. Okay, so there's all kinds of purposes in engineering for fitting curves to data. Hopefully I've motivated you at least somewhat that this is important. It really is a very important topic. So let's just kind of summarize the differences between regression and interpolation. Regression versus interpolation. Alright, so regression, we are finding curve that describes the trend of the data, finding curve that describes data trend. This is good for noisy data. And curve does not have to pass through data. Alright, interpolation. We are specifically trying to find the curve that passes through all the data. Through all data. It's good for data with little noise. Data with little noise. And commonly used to find intermediate points. Intermediate data. No, let's do intermediate points for tabulated data. Alright, in upcoming videos I'm going to talk about regression and interpolation. In the textbooks that we're using in my class, there's a chapter devoted to each of these, and actually I think there's 2 chapters devoted to regression. Let me see if I can figure out what the chapters are. Chapter 17 is least squares regression. So 17, and I think 18 is interpolation. Let me just check here. Yeah, 18. Yeah, chapter 18. That's in the Chaperon-Kennelly computer methods for engineers, or mathematical numerical methods for engineers. I can't remember the title right off the top of my head. Alright, so we'll see you in the next video. In the next video I'm going to describe just some basic statistics that we need in order to describe these processes. So we'll see you then.